Okay, thank you everyone. Welcome back to CPD in 43 for 2022. As you can see, we've got a great talk on decarbonisation sustainability of structural steel and hollow sections from Dave Chapman at Tata Steel. He's going to be running through presentation, and obviously, as the usual format, we're going to have a Q&A session towards the end. So we actively encourage everyone to ask questions throughout the talk to be fielded at the end of the event. And naturally, it's going to be running for roughly about 30 minutes of presentation from Dave, followed by roughly around 10 minutes slash 13 minutes of Q&A. We'll top and tail it with the intro and the conclusion. And just want to say thank you for everyone's support with the CPD in 43 events for the last year. Here's a number that we held over the last year. This isn't, I don't believe this is every single one, but this is a representation of all of the events that we had. But what I'll do now is I'm going to hand it straight over to Dave to do the talk. So Dave is from Tata Steel. He's going to be talking about all of this. He's comes from a background of designing stores, designing buildings that require steels in them. So he's very experienced in this area. So actively encourage questions fielded to him. If he's unable to do it, I'm going to, if he's able to answer the questions during the talk, I'm going to share his email and his phone number in the chat. So please do take that down, and you'll be able to contact him post talk. We will also be making this presentation available via PDF to all the people that have signed up via Eventbrite. So without further ado, I'm going to hand it straight over to Dave.
Thank you, Usman, and just double checking, can you hear me?
Yes, we can.
That's fine. Right, good afternoon all. My name's Dave Chapman. I'm a structural engineer with Tata Steel. My background is in the design of football stadia, high-rise buildings, and portable sheds. I was technical director of two large steelwork fabrication companies also. Now I just talk to engineers and other specifiers about steel and allied topics. Sustainability, we are putting some numbers to it, but there is still some philosophy in it. It's inevitable we're concentrating on CO2 and minimizing that, but it's still a case of if it costs twice as much or if it costs a lot of money, you know, is it worth it? Or if it's a case of we're harming people either in this country or abroad by what our actions do. So it's a combined aspect of that. Good philosophy. Tata Steel, the unit I work for deals with tubular sections, and it's not just construction. We produce tubes for machinery also and cranes, and of course chair legs and lamp posts and that sort of thing. This is what the British Standard says. We're talking about life cycle. I always say analysis, but life cycle assessment of a structure, and this is what the British Standard says. And it's divided, as you might see, into different bits. We can understand raw materials at one end, and in the middle we got the use of the building, and at the end there's reuse and demolition. And it's a case of you know, looking at these bits. For us, these first two aspects are easy to establish. We can measure these fairly easy in terms of CO2 equivalent. In the middle, not much for steel because it doesn't need much work. And just to be clear, we're talking about embodied energy in the structure here. So not the operational energy. Operational energy is the lights and heating, etc. But our part's the embodied energy. When I first started talking about sustainability nearly 20 years ago, we used to say in the life of a building, 50 years, the operational energy would be 10 times as much as the embodied energy of the structure. But of course, tighter and tighter thermal requirements and air tightness requirements, and also greater controls on the M&E within the building, means that, you know, it is being claimed now carbon neutral buildings, or if you, I guess most are probably 3 times the operational energy as embodied, probably for many buildings at the moment. So things are getting better. So the point being that the embodied energy within a building to make it is becoming more and more important going forward, and that makes sense. But that's not just all of it. We've got to consider what does happen at the end of life, and these are different modules. So it's module A, B, C, D, and we'll talk about these a little bit more as we go along. Of course. A twee comment. If you leave us a skip out in the left, there's all sorts of materials in there, and when the fellas in the vans come past, you know, the bits they're interested in are the steel, the iron, and any other metals, things they can reuse. So, and then that's we know that's true. It has a value. Steel has a value. When I was at school, we had paper cups, and you know, plastic cups came into our vending machine, and you can see here they had the advertising strapline on the left-hand diagram says, what does it say? The plastic cup at toss-away prices, and this is where we are really. You know, despite plastics being recyclable, it's not always economical to recycle something. So therefore, a lot of it does go abroad to be recycled. It's not always cost positive to recycle things. So again, we're in this position. There was a group, the World Commission on Environment and Development, you know, that they came out with a report in 1987, daft as it sounds, and they said, you know, the big thing to think about is don't do something today that we might regret, you know, later in life. And we don't need to have any knee-jerk reactions. That we're a considered body of people making buildings and buildings for a long period. You know, we don't really know necessarily what's happening to wind turbine blades and batteries and things like that. Now then, steel, although it's a massive emitter of CO2, you know, along with other construction materials, you know, steel and concrete are probably, you know, over 10% of all emissions at the moment, which is huge. But there isn't anyone that can deal without steel. Okay, you know, it is I'll put it vital for our life. It is not possible to live without steel. And even this fella here, living off grid in his cabin, you know, he's used nails, he's used a saw, he's used a hammer, or chainsaw to get to that point. So steel is an enabler for our transition to a low energy or low carbon environment. And just to consider these aspects here. So we've got a few different activities, and up the vertical axis is how much steel is required to get these things off the ground. And then so just looking at the examples, not that much steel in a hydroelectric plant, but then we look at the other end, all these offshore wind, and the note on the bottom says for every megawatt of solar power it requires 150 tons of steel. So every megawatt. So it's wind power in that instance, sorry, offshore. So we need steel to get to zero carbon for the grid. And that's important. It's not an enemy, it's an enabler. We talked earlier about those different modules, and well, that to establish or to look into what different products the effect is, we need good data, and this is what comes in EPD, an environmental product declaration. And you see I've put around a box in red. These relate to the different modules that we saw in that British standard and how to look at things. And these are, you know, quite accurate figures which can be applied to different structures. Similarly with data, we're into transparency, and not just being made in Britain. Our steel, made in Wales and goes to different factories at Port Talbot. BIM data is available for everything, which helps. 6001, of course, steel is always recyclable, and we've got our own Type 3 EPDs, which are third-party accredited, and they get more points within a BREEAM assessment. The bottom one is work in progress. That WIP means people are asking for actual markings on the steel, so that 20 or 30 years time when a building's taken down, it can be used. It has been done already with hard stamping, but it's difficult when things are shot blasted and painted as well. But we're looking at QR codes for that. Now, how is that's how. So we looked at the philosophy of the industry and our method of measuring it. Let's have a look at what the steel industry is doing about getting down to net zero by 2050. Bit of chemistry here for those that did it at school. The equation shows that we've got iron ore and coke, coal, and at the end of it we get iron and carbon dioxide. That is just an unfortunate chemical balance. To get iron using coal, we will get carbon dioxide, and of course we try and capture and store as much as that we can. Bear in mind that where that coke is there going in, that's called reduction. So that the coal is used to take oxygen out of the iron ore, and that'll come up a bit later. But we're getting to the point down the bottom of the graph of diminishing returns. What else can be done? Well, for old oil and gas fields, we can pump those full of CO2, which is okay. I mean, good news is we make the pipes as well that does that, so that's handy. So we're allowing that. Top right, that CO2. I saw again in the news today that one food manufacturer was saying they're running out of CO2 in this country. It sounds ridiculous, doesn't it? But the CO2 can be caught and used by other processes and to make other things also. Bottom left, trying fancy technologies to reduce the amount of energy into processes, but I think that's not the important one. The important one is the one on the right. Now, remember before we talked about we're going to use coal as a reducing agent to get the oxygen out of the iron ore. We can currently use hydrogen, and that gets rid of all the CO2. And the byproduct being water. However, it's only at small scale currently, and the anticipation is that this won't be available until, I've put it at mid-30s, but it's 10-15 years away, but feasible, and it's been proven. So that's a big win. Don't get put off by this diagram. Up the horizontal axis is to do with reducing by the use of hydrogen. And remember, the hydrogen can, remember we can. This is allied with zero carbon electricity as well. We can use that, but also along the bottom, this is now zero carbon, and up the vertical axis is hydrogen use. I expect it will be somewhere in the middle of that. How we're going to achieve zero carbon for making steel. Okay, now that's making steel itself, the actual component pieces. But if we look at carbon neutral steel fabrication, this is what the BCSA, the British Constructional Steel Association, have come up with, and they've said, well, we're going to use these 6 steps, 17.5% on design and 15.5% better better recycling. I'm not sure about that one. Direct steel making, that's what I was talking about before, getting rid of the coal. And of course, electricity we use, that can come from the offshore providing. Carbon capture, we talked about that, and reducing transport. And really that means reducing or using non-fossil fuels for transport, but also reducing the weight of the structure. So again, there's plans how to do this as a steel industry and as a fabrication industry also. Okay, this is how, when we're back again to the numbers, how do we measure what's been done? There were maybe 3 or 4 competing methods of doing this, but for our industry in construction, it's reasonable that we adopt the structural engineers data allied with the method in the British standard. We saw those modules earlier, and this is it. So you can read, hopefully you can read, it says reinforcing bars on the top there. So it's 0.76. So it's either 0.76 kilograms per kilogram or 0.76 tons per ton. Doesn't matter, whichever way you look at it. And that's the energy intensity to make a ton of those described elements. Okay, now, importantly, if you looked at that, you could just read off those values, A1 to 3. Remember back to our diagram? That's just at the beginning. And there's another bit of philosophy here, an approach. This is what they're given in that short initial phrase. Okay, so we're given the one on the left is just saying we're only going to consider the first bit of construction, and then this is for not just steel elements in the MIStructE guidance, it's other things also. Or do we consider the full life cycle analysis on the right? Some people say the left, some people say the right. There are some materials that would benefit from just considering the aspect or the philosophy of the left, and steel benefits certainly from considering the whole life cycle, because it still has a value when it's recycled. Okay, so that's the philosophy of which numbers you take. And indeed, those certainly in the module D values we'll see later, they're given in the MIStructE guide. There are 2 methods of steel production. One uses less energy than the other. Why is that? And you might hear them termed as BOS method or BOF, basic oxygen furnace, or EAF, electric arc furnace. And these are both methods of steel production. And this is getting the steel out of the iron ore. Primary steel production, which is on the left, this is fresh steel. So we're making fresh steel, and that takes more energy. Of course it does. The electric arc furnace uses mainly scrap. Okay, and therefore it takes less energy to make that. And of course it has the benefit of being an electric process, which is ideal if it's off-grid electricity, or sorry, zero carbon electricity. Not quite as good quality steel when it's 100% scrap, but can have additional chemicals added which up the energy to make a lot of others. So some people still want fresh steel, particularly for car body pressing, things like that. It wants to be steel and malleable. But don't be fooled into using or considering EAF just because it's less energy, and I'll tell you why. So we make fresh steel. That goes into the market, whether it be buildings, washing machines, cars, or whatever, and that's captured at the end of its life. We're into very little steel goes to landfill because it's has a value as a first thing, and of course it's magnetic. It's deadly easy to salt as well. It's probably not 0%. It's probably less than 0.5%. So it's around in 0. And of the material that's recycled, say some of it goes to the EAF, and some of it goes to the BOS plant. So why wouldn't we just say use EAF? Because without primary steel making, there wouldn't be enough in the system to go into the EAF. So when we're talking about world needs, which currently are up to about, I think it's 1.9 gigatons last year, of that, you know, the EAF only produces 0.8 gigatons. So straight away, we think we're being economical, but it or good for the environment, but it means there won't be any steel. There won't be enough. So this is one of these overall sustainability aspects, not just considering the environment. So, right then, back to this table with a few more figures. If you look at the left-hand side, we can see the A1 to 3 elements and the ones in between, the other blue, green and red ones. There's not much of that for construction materials. But when we look at the right-hand side, this is module D. So whereas the energy input for A1 to 3 is positive, you can see that if you recycle something on the right-hand side, which is what's happening, there's a negative element there. Okay, so there's a beneficial element, and that makes sense. You know, if we buy a car, we expect to get something for it at the end of the day, or cashing in gold jewelry. There is a value to it. So if we consider some precise actual aspects of this, so open sections. This is British Steel in this country, 2.45 tons per ton. What about Europe then? So have I got Europe? Now that's interesting. If we bring in European steel, much lower, because they're mainly EAF in Europe. But reading along, the module D, the recycled element of it, is much greater for fresh steel than it is for EAF. Now it might sound a bit daft saying that. Well, how does a wagon load of steel know which route it's taken? It's because the second line there, the EAF line, they take the benefit at the beginning. I can't quite see it because underneath something, but so you look at the end there. So although the 2.45 and the 1.13 are miles apart clearly, if you look at the beneficial element, once they've been recycled, there's not a huge difference. I mean, it's a bit 0.85 bit against 0.72. So blooming what? That's hardly anything. If you think as well, I mentioned gold earlier, it takes the same energy to produce an ounce of gold as it does to produce a ton of steel. Just some benefit, just some idea there. And then things like aluminium, again, much greater energy to produce them. So, that aspect, 0.85 and 0.72 aren't too far apart. I'm just going to say one thing here. The third line down, bottom line, bottom two lines, other construction materials may not be certain of recycling, therefore module D may be ignored. Okay, steel will be recycled. Doesn't matter if it's 100 years time, it will still be recycled. Okay, we can be sure to use module D. And for those folks that say not, it's up to you to decide. Steel made from both steelmaking routes, similar carbon footprint, and we don't want to specify one from a certain route. I've seen it done. One engineer did specify it from EAF, and all it does, if everybody did it, all it would mean is in this country, rich country, we get the low carbon steel for a particular building, but globally it doesn't help. That's what we're trying to do with this sustainability and carbon reduction. Right, we're going to look at, we talked about steel, we talked about society, we talked about steel, and talked about what different people are doing about it, and tangibly doing about it. We're going to look at just tubes now, just seeing how we can use those sustainability, picking the right shape. An element in compression. We know a tube is more economical for compression. Of course, for bending, a universal beam is more efficient. We haven't spoken about this. I do talk on all sorts of things. If you want to get in contact with me for lunchtime CPDs on other topics, but please email me. But there's two different sorts of tubes. Not obvious when you first look at them. one's hot finished and one's cold formed. The majority are cold formed tubes that we would be using, but in construction, a lot more are hot finish, and in automotive as well. So what we're saying here is the first two lines. So we've got a 150, 150 by 5. That's a box section, so 150 squared by 5 wall thickness is about the same capacity as a 150, 150 by 6 cold formed. Okay. Now looking at the fourth line along, that fourth column along, fifth column along, you can see there's more energy required to produce the hot finished tube than there is the cold formed tube. But because it performs so much better, that additional energy input is offset, and you see there's still a slight advantage there of 4%. So it's a case of using something of higher quality, which uses less mass and less energy overall, because it performs better, if that makes sense. And that's naturally what we would do. Oops, sorry. Oop. Press a few buttons. Put all those boxes in. Okay, so that's the shape of material. Use the right production method. What about high strength steel? We're being pushed and pushed for high strength steel, as everyone is, and typically strength is 355, so S355, and we've been pushed to, and we can make S460 steel, so there it is, 30% stronger. Again, it costs a bit more money, but it is better for strength. We'll look at that now. So consider, don't worry about all the equations above it. This is just saying this is how we can calculate elements in compression. This is EC3 or 1993. 200 by 200 by 12 and a half. Again, box section has a capacity of 3,300, which is great. But if we went to 460, we can see that's much stronger, 4,300. That allows us to reduce the wall thickness, getting about the same sort of capacity. Okay, so really lightness is what counts in sustainability. Less mass we're putting on on site is better. Now, of course, we need mass for some things, so dampen vibration, and it helps with sound. But for CO2, it's better to have less. Now, what about energy? How does that affect it? So we've seen S460 is stronger, but what about in terms of energy? So we have our baseline, 400 was 17.5, and that's got capacity of 8,500. Then if we just skip the end one, same sort of capacity in round figures, much lighter, and that means the very last line, if we've got a 6 meter column, we've saved 330 kilograms of CO2 just on that one column by using a higher strength steel. Okay, so it's just worth thinking about, and it reduces the self weight of a structure as well, which is sometimes a very high proportion of the load. The actual, when I was doing 140 meter girders for football stadiums, the actual main structural element could be 30% of the total load. So the lighter you get that, the lighter the overall elements are, and you get this virtuous circle, and then the load go down. So okay, I'm nearly done. So we talked about structure. What about comparing it with other shape sections? Have you thought about how expensive painting is, or galvanizing is, or welding? There's a much greater perimeter around a universal column than around a tube. They are more expensive to make, not dramatically though. And what about weathering steel? You've probably seen this as a Angel of the North, that sort of thing. It's a steel that doesn't rust any further. It gets this patina on it, and used here in this fantastic tower in the middle of Denmark. It's called Adventure Tower, isn't it? There's rope walkways and zip lines and all that sort of thing around the forest, and it's 45 meters high, and it's just a continuous spiral with wooden planks on it. But this is weathering steel, and it doesn't need the maintenance and of course the painting that some things do, and it's popular with Network Rail and HS2. People like that really don't want to maintain things, and that's available now in hollow sections, because most weathering steel elements, motorway bridges, are made out of plate, but we're actually rolling them now if you're interested in weathering steel hollow section structures. That is it now. So, you know, the steel industry has a plan, Tata Steel has a plan, and tubes are good for enabling sustainability. And if you want to help folks in this country, there are ways of doing it. And I think I'm done. So thank you for listening. I didn't time it, but that looks about half an hour.
Great, thank you for that. So I just want to kick it off with, obviously, please, everybody, if you have any questions, please do field it in the chat box. What I'll do is I'll start it off. I'm just very mindful that you used a number of acronyms. So
I'm sorry.
No, it's fine. To be honest, it's we all do it, but I just want to sort of go over a couple of them. But also, if you could just sort of go through maybe a few others that you may have used. So you mentioned EAF steel.
Oh, I'm sorry. Electric arc furnace. I'm very
Yeah.
sorry if I.
No, it's fine.
My fault. Yep.
It's just it allows everyone else to go away and sort of look into that a bit more. And then I believe you also said BOS.
Yeah, basic oxygen steel making, that is.
Okay. And then if you could also elaborate on cold form and hot formed as well, please, hot rolled, etc.
I can, but that's another talk for another day, really.
Maybe in a couple of sentences.
Right. If you bend a paperclip, okay, to a certain shape, and you stop and let it go, what happens? It springs back a bit, doesn't it? Okay, so you always have to bend it further than you want it to get it. Cold form tubes, we make them out of a flat plate into a circle and then weld them along the line. Those have got internal stresses within that if cut, would want to spring open again. That member, if it's been hot finished, has been put in the furnace again, and all the grain structures relax. There's no internal forces. So it's an additional process producing a better quality tube is the hot finish one. In truth, most engineers will specify hot finished. But if you're doing balustrading or something, you might, cold forms is fine.
Yeah, no, exactly. And it's interesting as well, you mentioned about the, in essence, the very, very long life in regard to recycling steel, because it could be sitting on the side somewhere. Obviously, there's corrosion, etc., but just generally, the premise still stands in regard to sort of it being recycled for many, many years. So that was quite interesting as well. And it's
sorry,
really
just on that, the average time for recycling of a piece of steel is about 38 years.
okay.
Cars are quicker, money is quicker, but structures are not. But go ahead, sorry. Yep.
No. It's just, thank you for adding that in. And then also as well, you mentioned sort of the sort of the dynamics of actually. Oh, let me just take that off. So just desktop. Sorry, I'll just leave that. So you mentioned in addition, you mentioned about sort of thinking about the form of the steel, the density of the steel, and also sort of understanding the sections of the steel that's going to be specified within a said project. That's very interesting as well, because in our experience from our firm, we end up having quite a lot lengthy discussions with the engineers that we're working with, to not only address a particular issue or concern, but also understand exactly the various options that could be proposed for a said scheme. And you've obviously added the added dynamic of sustainability. What can we do in regard to density, surface area for painting, for galvanizing, for example. But
Yep.
then also as well, like you briefly touched on, is there's the other elements in regard to why the steel might be required in the first place. So it's very interesting, and sort of
Yep.
would encourage further reading for everybody.
Just on that, it was, beg your pardon, it was the strength I was talking about that changes, that not that it doesn't affect the density, so it's still the
Uh,
same weight. But what I'm saying is, I should have said, by using a higher strength steel
mhm,
allows a lighter weight element to be considered. So
yeah.
it becomes lighter from that point, but by being stronger
Okay, great.
of the density.
Um, doesn't look like we've got any questions coming in, so I feel like I've asked everything that sort of comes to mind to myself. Um, so what I'll do in that case then is I'm going to just share my screen and
I mean, if I just say one other thing, it's
yeah, please do.
we although I'm a structure engineer, we have a department of sustainability people at our work, so who can answer quite tricky questions if needs be. So it's not just me; it's we've probably got 10 folks just dealing with sustainability. If
No,
you
no,
need
I
any
understand.
answers,
Yeah. Um, so I'm just going to show a couple of. So thank you very much, Dave, for the talk from Tata. It was
pleasure.
very
Thank you.
informative and very detailed. Hopefully, that gives a lot of people food for thought in regard to sort of specifying steel and also working with the engineers that they're working with. Moving forward on schemes that they're currently working on, or we're going to be working on, and it's very interesting to see how this develops. So we've got a couple of other events which I'm just going to release via looking at the websites of the speakers that we're going to be talking. So for February, we've got a very interesting piece of software that's been developed by a company called Yemitech. They actually analyze demographics and sort of various a range of variables in regard to data analysis on how to design better and consider better ideas for schemes based on the range of metrics. Hopefully, the visual that you can see in front sort of gives a sort of a flavour of the idea. It will be sent out via normal channels. So please do keep a lookout for that. It is extremely interesting. I've had uh, a talk with the founder of this software, and it's very, very interesting. 15-minute neighborhood, understanding sort of food poverty and so on, sort of deserts of various types in regard to sort of services. So it's really interesting. So I do actively encourage you guys to sign up and attend this on in February. We will release the information in due course. And then our March event is going to be a building control update. I don't know whether everyone's aware, but there was a update in with building regs in December to a number of the approved documents, and just generally a good sort of roundup and update in regard to building regulations is never a bad thing. So we've asked Cook Brown Building Control to do that for us. So we look forward to them speaking in March. We do have other events scheduled in for the rest of the year as well, but we're going to be releasing them one by one or during the events that we have, and then advertising it um, on the channels that we have to hand. Just to cover the questions that we often get is all you need to do is go into YouTube and type CPD in 43, and there you go. You've got all the talks that we've done up on YouTube. You just need to click on the talk, or for example, if you go to Science Technologist, and there is our very own dedicated section which has CPD and 43 Wessex Region webinars, and you should be able to go in there and see a huge range of talks that are on there. So just wanted to sort of do that just to make it very, very straightforward and sort of highlight exactly how you can get onto those for your own listening in your own time. So I just want to say thank you again to Dave. Thank you to Wales, Site Wessex, for helping arrange this event today. It's been very well attended, and it's lovely to see you all again for our series of events for 2022. Great to kick it off with sort of a deep dive in regard to sort of the dynamics of steel, and we look forward to seeing you in our events. Obviously, with the February and the March one being released exclusively on this talk, and they'll be advertised via our channels. So please do sign up as soon as, and also please do invite your colleagues to come along. So thank you, everybody, and look forward to seeing you soon.
Thanks for listening again.